So differentiability of a function, if we want to learn, graphs of function to answer many questions will help. Continuity of function important. We'll do differentiability in an interval by knowing differentiability at a point. Before we do differentiability at a point, to understand the concept of differentiability at a point, let me remind you the differentiation of a function at a point x equal to a. If dash a, when you are going to write, it will be limit x tending to a fx minus fa by x minus a. Sometimes we replace the point x equal to a, that we write x equal to a plus h. So x tending to a will imply what? This will imply that h equal to 0. So we can rewrite this definition: limit h tending to 0 f of a plus h minus fa by h. Okay. So if dash a, you can, this thing you can express this form, or f of a plus h minus fa by h. This is done by you already. Geometrically, this will represent, this is dy by dx at x equal to a, and this is basically slope of tangent at x equal to a. Now, if the function is differentiable, for a differentiable function, the above limit, the limit h tending to 0 f of a plus h minus fa by h must exist. Okay, that is limit h tending to 0 minus, or you write 0 only, not 0 minus, h tending to 0 f of a minus h minus fa by minus h will be f of a plus h minus fa by h. These two must exist and they must be equal for differentiability at a point. Okay? This limit is called left hand derivative at x equal to a, and this is called right hand derivative at x equal to a. Okay? So what is the difference when you use first principle for derivative only and taking differentiability at a point? There in class 11 syllabus, you have differentiated lot many functions by differentiation, by chain rule, by all those things, product rule, sum rule. But here, you are going to check whether you can find derivative at a particular point or not. existence of derivative matters. Before differentiation, we should take care of this part. Can I differentiate there? So it depends on existence of this limit. If the limit exists, then differentiable. If the limit doesn't exist, it will not be differentiable. Let us take a very common function. Check the differentiability of check differentiability just by this definition of fx equal to mod x minus 1 at x equal to 1. It's an NCT problem or NCT type of problem I am asking. Okay, many sums are not given in NCT book, this one only given. Check different or mod x minus 2, I don't remember. Check differentiability of this function at x equal to 1. So we'll be checking left hand limit and right hand limit. Before doing it, we need to define the function. So you write fx is x minus 1 for x greater than or equal to 1 minus of x minus 1 for x less than 1. Okay. This is the definition of mod x minus 1. You are going to check differentiability at x equal to 1. Now let us define f dash 1. This is limit h tending to 0 f of 1 plus h minus f1 by h. Okay, for a f dash 1, you can write this way also. F dash 1 is limit x tending to 1 fx minus f1 by x minus 1. But when the question is on checking the limit, then this form will help a lot. We can refer this one as the limit for both left and right hand. Left hand, how will you write? That we have seen a left dash 1, h tending to 0, f of 1 minus h, f1 by minus h. Okay. So this is, and r f dash 1 is itself only. You write r f dash 1 once more. This is limit h tending to 0, 1 plus h, all h are positive here. So what happens, the values of a f dash 1 and r f dash 1 for this function, a f dash 1, if we do, it will be limit h tending to 0, f of 1 minus h minus f1 by minus h, you know. Which part is 1 minus h? This part. Substitute there. So limit h tending to 0, f of 1 minus h minus of 1 minus h minus 1, f1, this divided by minus h. Everything get cancelled except h by minus h. So a left dash 1 is minus 1. Okay. What about r f dash 1? One plus h minus f1 by h. Okay. So this will be limit h tending to 0, f1 plus h. Look at the function. This part is greater than. So we'll be using that. 1 plus h and f1 you get there only. This divided by h. This is equal to 1. So since a left dash 1 not equal to r f dash 1, this will imply that the given function is non-differentiable at x equal to 1. Okay? It is non-differentiable at x equal to 1. Let me explain one more sum so that the very first concept of differentiability be clear to you first. I am defining a function like this, f(x) equal to x square plus 3 for x greater than or equal to 1, and this is 3x minus 2 for x less than 1. Is this function differentiable? Let us check. Here a f dash 1, we write f dash 1 that way first. Okay, as we have done one case with 1, let me take it 0 here. But 1 is more interesting case, so I'll keep 1 over there. So let us write f dash 1. So this will be a limit h tending to 0, that is f of 1 plus h minus f1 by h. So a f dash 1 will be what? H tending to 0, 1 minus h f1 by h. 1 minus h is this part, you write 1 minus h. 3 into 1 minus h. Yes, it will be minus h. Minus 2 minus f1. f1 if you take this divided by minus h. So this is going to be 3 minus 3 is 0. This is 3 minus 3 0 minus 3h minus 3, that divided by minus h. You will stop your calculation here because this is 3 plus limit h tending to 0, 3 by h. This one does not exist. If this one doesn't exist, then it will not be differentiable there. Does not exist. Okay? Therefore, f(x) is not differentiable at x equal to 1. We need not do Rf dash 1. This will not bring anything extra for us. Okay? Let us take third type of problem where trigonometry is involved. f(x) equal to x square sine 1 by x, 0 for x equal to 0. Check differentiability at x equal to 0. Differentiability at x equal to 0 to be verified. Let me do it with the definition we have already got. So f dash 0 we are going to check. We write it first. Limit h tending to 0, 0 plus h, f0 by h. I did not find the left hand limit and the right hand limit separately. Why? Because this function is not given for less than 0, right hand 0, no modulo function is not there, so that you can break it and write different function. That is also not possible. So what to do here? We ordinarily calculate this limit. This is nothing but what? Limit h tending to 0, fh minus 0 by h. So we'll be calculating this only. H square sine 1 by h minus 0 by h. So this will be h tending to 0, h sine 1 by h. 0 into a finite quantity between -1 and +1. So the result is going to be equal to 0. Okay? So the function is differentiable at x equal to 0. But this function is a very special one because with x square sine 1 by x, you are getting differentiable. With x sine 1 by x, you can't. With sine 1 by x, you can't. But if it is x cube sine 1 by x, x4 sine 1 by x, you can do it. So based on that, I'll be setting another problem for you. Let fx equal to x to the power m sine 1 by x not equal to 0, 0 for x equal to 0. Check differentiability at x equal to 0, or question may be asked this way also. Show that the above function is differentiable for x greater than 1. Sorry, not x, it will be m greater than 1, but not differentiable for m less than or equal to 1. See how to answer the question here. You write f dash 0 only. F dash 0 is what? Fh minus f0 by h. What is h over there? Sine 1 by h, 0 by h. So this is limit h tending to 0, h to the power m minus 1 sine 1 by h. Clear? So obviously this limit exists for m greater than 1. For equal to 1, let me do those cases. For m greater than 1, limit h tending to 0, m minus 1 sine 1 by h. M greater than 1 means h remain in the numerator. So this we can write 0 to the power m minus 1 into sine always lying between minus 1 and plus 1, a finite quantity between -1 and +1. So the function is, what's the value of this then? This is going to be equal to 0. So the function is differentiable at x equal to 0 when m greater than 1. But for m less than equal to 1, do it m equal to 1 first. For m equal to 1, f dash 0 going to be h to the power 1 minus 1, isn't it? 0 h to the power 1 minus 1 sine 1 by h. So this part is just sine. This limit doesn't exist because this will tell you a finite quantity which is oscillating between -1 and +1. A finite quantity lying between -1 and +1. So this is oscillatory. This implies that limit doesn't exist. So it will not be differentiable. Limit does not exist. Now for m less than 1, let m less than 1. This implies what? M minus 1 less than 0. Okay? Let m minus 1 equal to minus n. So the limit will be what? Limit h tending to 0, h to the power minus n, you can see this part, into sine 1 by h. So this will be 1 by h to the power n sine 1 by h. This doesn't exist because something by 0 is coming, no? This limit does not exist. So not differentiable. When m less than 1, then also not differentiable. Because I have... Yes, yes. So it will be undefined one. It is not differentiable there. Now, geometrically, what is happening there, let us try to understand. Okay? I am going to explain the geometrical meaning of differentiability. What is that? To explain the geometrical meaning of differentiability, answering MCQs will be very interesting if you remember this MCQ method. MCQ method is very interesting. What is that? You take the graph of function like this. Okay? At the point x equal to c or a, whatever, you are going to find derivative. What does it? At this point, a means if the function is y equal to fx, then coordinate of this point, the point P, wait a minute, the point P, a comma fa, this point where you are going to find dy by dx at x equal to a. You know the geometrical meaning. This is slope of tangent. But when you consider left-hand derivative, there is a point Q. This is A minus H. H is a positive quantity, should remember. And there is another point which is R. R is A plus H, F of A plus H. Okay? So this point QP is there. Q to P is there. This is the chord. This is not tangent. I am drawing another chord over there. Okay? Now, this chord, that PQ or PR, PQ or PR, whatever you say, PQ and PR also you can say that PQ and PR, if you do, then PQ and PR, if you do, those slopes are going to be different. Agree or not? Because for PQ slope, MPQ is what? FA minus H by minus H. What is MPR? This is for PR only. MPR is what? That is y2 minus y1 by x2 minus x1. This is also equal to 8. So MPQ you got, MPR also you got. Are they equal? If they are equal, under what condition they will be equal, we have to investigate. Firstly, they are not equal. It looks like that they are not equal. And dy by dx at x equal to a, if you find dy by dx at x equal to a is limit h tending to 0, f of a plus h minus fa by h. Can they be equal to this or this? Because when you draw tangent at the point P, then value of this limit is slope of tangent. If this angle is theta, then this is actually tan theta. Okay? But here, if you join, that will not be equal to theta. If you join this also, that won't be equal to theta. But in the limiting case, when h is tending to 0, they may be same. Okay? When h tending to 0, this limit fa minus h by minus h, and this one you can change also. This will be f of a plus h minus fa by h. They may be equal. Okay? These two must be equal. Just wait a minute. Probably I have done a sign mistake over there. This will be plus h, because you have written this minus this by this minus this. So it will be plus h. When h tending to 0, these two limits will give you what? These two limits will be equal. For differentiability at the point A, we have seen that these two must be equal. So in this diagram, In the diagram I have given that MPQ, slope of PQ, if they are equal by any method, MPR, if they are equal, then that is going to be slope of tangent at that point, tan theta. You can see the diagram. If you imagine that that is being rotated. PQ, under what condition? When h is very small. H is very small means R is very small. What does it imply? R is very close to P. Q is also very close to P. In that case, MPQ equal to ampere equal to tangent, tan theta. So MPQ is what? Limit PQ found here. PQ is this part. That limit f of a minus h minus fa by minus h. This is equal to f of a plus h minus fa by h. Okay? That is equal to dy by dx at x equal to a. We can think with different manner. Suppose somebody has claimed that I have drawn a tangent here. For that graph only, I am going to tell you that at x equal to a, nothing else. It is dy by dx at x equal to, just notation. Now for this graph, this is the point P. Whatever we have taken there, same symbol, same notation we take. This is Q and this is R. Q. Okay? You can easily draw a tangent at x equal to R. I mean, at the point R. You can easily draw a tangent at, just a minute, at the point Q. You have drawn tangent at the point P also. Okay? Now, these tangents, will coincide. What does it mean? Q will be tending to P, R will be tending to P, then only it is possible. Means, separate tangent. If you claim that I have got a separate tangent, that is not possible. So, differentiability at a point implies that there is an unique tangent. Two tangents are not possible. Differentiability at a point means two tangents are not possible, there will be unique tangent. It solves many problems. Even when you are about to discuss, continue with our first problem today, fx equal to mod x minus 1. I am just telling you. You all know the graph of this function very well. If you plot the graph of this function, mod x minus 1, this is just by shifting the origin for mod x. It will be from x equal to 1 and the graph has two branches. From graph only we can decide the function is not differentiable at 1, 0. Okay? At the point x equal to 1, the function not differentiable because tangent is not unique over there. So at a point tangent is not unique, it will not be differentiable over there. Case is true for mod 2x plus 1. Everyone will say it is continuous, I know. You are saying difference, not differentiable. Yes, continuous function like this thing, it is continuous at x equal to 1, but not differentiable there. Not differentiable at x equal to 1. It can't be differentiable there. This is true for all mod function. For mod x, you see the graph. This is for mod x. It is not differentiable at x equal to 0. Okay? If you draw the graph of this function, fx equal to mod x minus 1 plus mod x plus 1. This function will not be differentiable at x equal to minus 1 and x equal to 1. This particular boat function, why boat? It takes the shape of a boat. When you plot the graph, it is not differentiable. X, y, this point is 1 comma 0, this is minus 1 comma 0. In between minus 1 plus 1, this function has this form. You may write or you don't write. The graph of the function will be like this. Okay? So it will not be differentiable at x equal to minus 1. Why? Because at x equal to 1, this point A, there is no unique tangent over there. So it will not be differentiable. It is continuous at minus 1 and plus 1, but this both function is take the shape of a boat. That's why I named this one as boat function. Boat function not differentiable. BOAT, boat. Boat. Take the shape of a boat. That's why you are referring this one as a boat function. This boat function is not differentiable at x equal to minus 1, and you can take any one of them. That is mod x minus 2, mod x plus 2. If you plot the graph of this function, you will observe that not differentiable at x equal to 0, minus 2 and plus 2. Okay, you must try to plot it. Clear? So if the function doesn't have unique tangent at a point, it will not be differentiable there. You can check, you can proceed this for any modern modular function. There is no chance of differentiability. If x equal to modulo x, not differentiable at any point. No, not differentiable for x belongs to I, the set of integers. Otherwise, it is differentiable. Why? If you consider the graph of the function, just I explain the graph of modulo function, rough sketch. Yes, at integer point, it has different limiting values. So the graph of the function is like this. Yes, it's like this. It is not differentiable at integral points 1, 2, 3, 4. Here limit only doesn't exist. So it will encourage us to find out the relationship between continuity and differentiability. Let us find it. Relation between continuity and if a function is differentiable at a point, this will imply that the function is continuous there. Differentiability will imply continuity. But we have already seen that continuity never, sometimes it does, but not always it will imply differentiability. Like in case of modulus function, mod x minus 1, we have seen that the function is continuous at x equal to 1, but it is not differentiable there. But how to prove this part, that a differentiable function at a point must be continuous over there? Imagine the function, let fx, the function, be continuous at x equal to k. Assume this. The function is continuous at x equal to k. So what does this mean? That f dash k equal to limit x tending to k fx minus fk by x minus k. This limit will have a finite value. This is a finite quantity. So if the function differentiable at a point, this f dash k at the point x equal to k, then f dash k has a finite value. Now, by assuming this, it's a finite quantity, we are going to prove that it is continuous also. It means to prove that limit x tending to k fx must be equal to fk under this assumption. What assumption? That it is differentiable there, it's a finite quantity. F dash k. Now, limit x tending to k fx minus fk, this thing we can express as limit x tending to k fx minus fk by x minus k. We can divide by x minus k as x minus k not equal to 0. Isn't it? X is tending to k, but x is not exactly equal to k. So this you can divide and multiply. Clear? Multiplied and divided by x minus k. So this will be fx minus fk by this multiplied by limit x tending to k x minus k. This one is a finite quantity we have assumed there. This part is a finite quantity. So a finite quantity multiplied by x tending to k x minus k will be what? K minus k, this is equal to 0. So this part is 0. So which part have we got 0? Limit x tending to k fx minus fk is 0. This implies that limit x tending to k fx is equal to fk. Okay, so the function is continuous over there. Under what condition? The function is differentiable. That's why it is continuous. So differentiability will imply continuity of the function. If a function differentiable at a point, it must be continuous over there. Clear? Let us apply this thing to solve a problem here, that find A and B. Question is this, textbook problem. Find A and B so that the function fx equal to x square plus 3x plus a if x less than equal to 1, bx plus 2 if x greater than 1 is differentiable at x equal to 1. Okay, let us solve this sum. You have to find the values of a and b so that the function is differentiable at x equal to 1. What theorem we have just proved, that we are going to use here now. That continuing differentiability at a point implies differentiability at x equal to 1 implies continuity at the point. So therefore, limit x tending to 1 fx, I mean 1 minus fx, left hand limit, equal to limit x tending to 1 plus fx is equal to f1. 1 minus which part you take? This part. That is 1 square 3 into 1 plus a, 1 plus this part, b into 1 plus 2. This part you don't take, we have already used. So 4 plus a equal to b plus 2. Therefore, one condition we got by using continuity only. Let us go for using differentiability now. As the function is differentiable, at x equal to 1, see, this sum you can do by the method a left dash 1 is equal to r f dash 1. Okay, left hand limit at x equal to 1 equal to right hand limit at x equal to 1. If you are answering MCQ, then I could have told you just get it by differentiating the function over that point. Okay, you can have several logic, like it's a polynomial function, it must be differentiable over there. We can differentiate every point. There is no point where it is non-differentiable. Okay, so that you do for MCQ and for all entrance exam, but for board exam if it arises, I request you to apply this definition of derivative there. Okay, I am using my vast experience in teaching CBSE board. I know what board people want. I mean, what is expected from a student. The technique you will apply for MCQ, definitely I'll show you in future at least one sum today. But this one I'll like to do by this method while limit involves. So it will be what? Limit h tending to 0, f of, this is not 1 plus h, this will be 1 minus h f1 by minus h must be equal to h tending to 0 f of 1 plus h minus f1 by h, isn't it? So you just put the value of f1 minus h over there. So this implies what? Let me finish it here. Limit f of 1 minus h will be using this part. So 1 minus h whole square, 3 1 minus h plus a minus f1. For f1 also we use the same part. That divided by minus h will be equal to the right hand limit. That is limit h tending to 0 f1 plus h b into 1 plus h plus 2, that divided by b into 1 plus h plus 2 minus f1. f1 will have the same value, that is by putting x equal to 1 over there. That is minus 1 plus 3 plus a, that divided by h. So let us simplify it. H tending to 0, 1 minus 2h, h square, 3 minus 3h, plus a minus 4 minus a by minus h equal to limit h tending to 0 b into 1 plus h, b into 1 plus h, 2 minus 4 minus 2 minus a. This divided by h. Clear? So 3 plus 1, this 4 get cancelled, a also. So this implies h square minus 5h by minus h under the condition h tending to 0 will be h tending to 0. This condition you can check once, that b equal to a plus 2. So this minus 2 minus a you can replace by b, that divided by h. So this implies this is minus h plus 5. Here this b and minus b get cancelled. Limit h tending to 0 bh by h. These two get cancelled. So 5 is equal to b. H tending to 0. H is not equal to 0. So b equal to 5. Therefore, a equal to 5 minus 2. Hope you have understood. By using the concept that differentiability will imply continuity, we have done it here. And then I have used that limit concept, a left dash 1 equal to r left dash 1. Clear? Hope you have understood. Now let us go for NCERT exemplar sum. This sum I have chosen for this session. Let us do it. Examine the differentiability of f where f is defined by this thing, that fx equal to x into modulo x for x greater than equal to 0 less than 2, x into x minus 1 for x greater than equal to 2 less than 3. Whenever this kind of problem arises, you will always rewrite the function. fx equal to x into modulo x under what condition? Because 0 to 2 whole thing is covered, so you will write 1 here. This is one interval where modulo x can be defined, and this one also we also can define in the interval greater than or equal to 1 less than 2. And this one as before, x minus 1 multiplied by x, that is okay. What is the value of modulo x in this interval? Rewrite it again. Rewriting the function, fx will be in this interval value is 0. When x greater than or equal to 0 less than 1, modulo x is 0. And here in this interval maximum integer value is 1. In this interval no change. So again we rewrite. Again rewriting the function fx equal to 0 when x greater than or equal to 0 less than 1. This is x for x greater than 1 less than 2, and this thing is x minus 1 for less than 3. So here I will be using that technique. Since it is a polynomial function, differentiable everyone, I was telling you, no. One sum I will show you by using that differentiation concept, direct differentiation. This is the sum. You have to state that between 0 and 1 there is no problem. It is a constant function 0. Between 1 and 2 there is no problem because it is a polynomial function. You can differentiate anywhere. This is also a polynomial function x square minus x between 2 and 3. But the problem arises at the junction. If there is, if you draw the graph, you can get it nicely. But that graphical method we have done. This time I'm just showing you by direct differentiation method how to get this. Just before 1, you check at 1 and 2, then everywhere it is differentiable. Only 1 and 2, they might have different slopes. We check that a left dash 0, a left dash 1, the value is 0. R left dash 1, how to get? That is differentiating this function and putting x equal to 1. fx is x. What is f dash x? It is 1. So r f dash 1 is 1. Okay? So not differentiable, you have to write the comment over there. Function not differentiable at x equal to 0, no, at x equal to 1. You must agree. Now, what about the point x equal to 2? Is it differentiable over there? Just when x greater than or equal to 2, that fx is x square minus x. You just check. F dash x is 2x minus 1. So at x equal to 2, a left dash 2 you will be getting by putting it there. That is 1. And r f dash 2, differentiate and put there. 2 into 2 minus 1, that is 3. Okay? But if this is the question asked in descriptive paper, my request, you do it by previous sum method. Otherwise, you might lose some marks. In marking scheme, this method is not allowed. You will not get marks. I mean, step mark you will get. So, it is not differentiable at x equal to 2 also. It is differentiable This function is differentiable everywhere except x equal to 1 and x equal to 2. Got it? Hope you have understood. Now, this is another exemplar, very good problem. So I'd like to discuss with you today. Sum is this. Just check once. It's the exemplar book problem here, that a function f r to r satisfies the equation. What equation? Fx plus y equal to fx into fy. For all xy belongs to r and fx not equal to 0. The function given to be differentiable at 0 and f dash 0 2 show that f dash x equal to 2fx. Bit difficult, but exemplar book it is there. This question may be asked in your board as well as in entrance exam. It is differentiable at x equal to 0. What does it mean? It is a finite quantity and they have given the value. F dash 0 equal to 2. What is f dash 0? Let us simplify it first. If you get some clue from there, you must go for it. F dash 0 equal to 2 implies limit h tending to 0, fh minus f0 by h exists and its value equal to 2. Whatever given, let us write first. Now, f dash x is what? Is equal to limit h tending to 0, f of x plus h minus fx by h. Isn't it? What is fx plus h? Fx plus y is given. So you write accordingly. Fx, fh. So it will be limit h tending to 0, fx as common, fh minus 1 by h. What about fx? Limit will not work on it. It will work on the remaining term, that is fh minus 1 by h. And what is the value of this thing? That is 2. We have seen that here. So it is 2fx. Such a nice sum. You can do it in the least possible time if you try. Okay? All the best. Next session, I am coming with differentiability only, but we have the duty to start from past year's questions. Okay? And some more conceptual part I'll be discussing. Thank you for staying with me.